All right, so let's take a look at our graph. What's the a value? Is it positive or negative? Talk to your partner. 5 seconds. How do you know? On the count of 3, 1, 2, 3. Negative. Right? Why? Because it's pointing where? Down. It's pointing down because the degree of this function is? It's an even. Remember, the easiest even is? 2. X squared. So I know it's an even because the arrows are in the same direction. I know it's a negative because it's supposed to be opening, starts up, ends up, but this one's down and down. Okay? Alright, this one's going to be a little more difficult for us. Brian M., read C for us, please. Alright, this is yesterday's lesson. Let's count the number of just extrema. Put your finger on the first one. Count. Ready, set, go.
1, 2, 3, 4, 5.
So we have 5 extrema in this problem. Okay. Yesterday, we put a star by the big idea. Find the star on the previous pages that we did yesterday and tell your partner. You guys have 15 seconds.
Oh, max than the extrema. One less than the degree.
Pamela, what was the big idea? We had stars by it. The max number of extrema is equal to the degree less than 1 or minus 1. Yes? Yeah. So great one to add to your formula sheet. So the question is, can this function be a 6th degree polynomial? Well, I have 5 extrema, so I'm going to put 5 into here. So I get 5 equals the degree of our polynomial minus 1. And let's treat that like an x. So to remove the negative 1, I'm going to add 1. So my degree is equal to 6. So the answer is, can it? Yes. Because the max number of extrema is 5. And we have that on our graph. Okay, these next ones will be new. Dayanara, can you read D for us, please? Alright, you may have learned this in a different class, but I will teach it to you like the first time. Domain refers to the, anyone know? Which axis? The x-axis. And the x-axis goes in which directions? Okay, watch this. I want you to go in a specific order. I want you to go to left to right. The domain refers to the x-axis, and you will go in this direction. Using your pencil or pen, you will go from the left to the right. Now, let me say, it does not matter where the arrow is pointing. What matters is that you just have an arrow. So, let me show you the answer, then I'll explain it. So, as I go from left to right, the first thing I touch is the arrow. Although the arrow is pointing down, I'm not concerned about it. What I'm concerned about is I'm touching an arrow, because basically an arrow says you can have the graph going way over here. That's saying you can pick all of the negative numbers. That's why I'm going to write negative infinity. It's coming from negative infinity. As I keep going on my roller coaster, the last thing I touch on the roller coaster going from left to right is another arrow. The arrow says it doesn't matter it's pointing down, it's just saying that there's values going in this direction. Because remember, it can continue on, and so basically I'm going towards positive infinity. The range, which axis do you think that is? The y-axis. Oh, this is this question. And which direction do you think I'm going from? Okay, you could think of the opposite, but the y-axis goes in which direction? Up and down, so I have a phrase, bottom to top. Say that.
Bottom to top.
So we're going to go, take your pencil now, pen. We're going to start from the bottom, and then we're going to end at the top. The first thing I touch is the what? The arrows. Now, it's not about where the arrows are pointing. Down here, the y values are what? Negative. That's why this is called negative infinity. So we're going to write negative infinity. Now, the last thing we touch is it an arrow? No, the last thing we touch is right here. And remember, the range refers to which axis?
Y-axis.
So this number on the y-axis is around 2.2. I just kind of estimated there. So I'm going to stop at 2.2. And we actually changed the symbols to a bracket. So this is called interval notation. A bracket says you basically stop at 2.2 and include 2.2. Okay? So that was the domain and the range. So that was D and E. 2 more letters, 3 more letters, we're almost there. Determine the number of relative extrema in this class. In this graph. How many relative extrema do we have, class?
5.
1, 2, 3, 4, 5. We have 5. Determine the number of absolute extrema in this graph. Partner B, tell partner A. Where does that go? Keyword, absolute. On the count of 3, ready? The number is 1, 2, 3.
3, 1.
Okay, let's look. Wait. Let's look at our graph.
Oh, wait, I was wrong.
In this problem, we assume that the graph keeps going down, right? So this here would be our absolute. So we can have 1. It's implied in this graph that the graph keeps going down, most likely. So we're going to say 1. Here is a new part. State the intervals which the graph is decreasing. I'll use my orange highlighter here. Decreasing as we go from left to right is where the roller coaster is going down. So I'm going to highlight all the parts that are going down. Whee! 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 So we have 3 intervals. What's new is how to write these intervals. So you're going down on the roller coaster, you're going to use the x values. So maybe like -3 to about maybe like -1.5. That's the first orange mark. And I'm going to join that, or put it in union. That looks like a U, so it's not a U, but then from here, maybe like 0.2 on the x-axis to about maybe 2. And then this last orange mark where it's decreasing is from basically like 3 to now infinity, because it keeps going down forever. So maybe like 3 towards infinity. So some new concepts, right? C was yesterday's lesson. Something that might be new to this class is domain and range, and then figure out where it's decreasing.